All right. Here we go. Today, the plan is to just take some questions from you guys, do a little bit of review stuff, talk about whatever it is that's, been kind of weighing on you guys, and get in, get out, and give you some time to work on your stuff. Sound okay? All right. Who wants to start here? Blake, as usual. We'll go with you.
Would you mind doing number? Let's start with 79 on 5.5.
5.5, 79. Hold on a second. I was a little, in my efforts to get started, I forgot to open up the PDFs for me to screen cap, but I'll get it.
Take your time. Don't be worried.
Oh, I'm worried.
Oh.
No, I'm not worried. It'll be fine. All right. 79 on 5.5. All right. So it says, which of the following areas are equal? So one thing I could do is I could do the integral for each of them and see if they have the same area, right? Or what I'm going to do is I'm going to set up the U substitution and alter the bounds and just see if the integrals are the same. Because that'll still be the same as, if it's the same integral, it's got to have the same area, right? So that's going to be my plan. So for the first one, we have the integral from 0 to 1, e to the square root x dx. So to set up my u substitution, I would say u should be the square root of x. Du dx then would be 1/2 x to the negative 1/2. So du should be 1/2 x to the negative 1/2. Dx, thank you. I'll multiply the 2 over, but there's nothing I can do about that x to the negative 1/2. But I notice here that u is the same as x to the 1/2. So 1 over u should equal x to the negative 1/2. So we can write this as the integral of e to the u times 1 over u times 2 du. So I'll just put the 2 out front and the du in right there. And then I need to adjust my bounds now. So u of 0 is the square root of 0. U of 1 is the square root of 1, so we're still going 0 to 1. So that's the first area. Let's look at the next one. Okay.
Is that u of x?
Yes.
Yeah, that's right.
Yeah. So I'll do it in a different color here. So I have the integral from 0 to 1 of 2x e to the x dx. So to start here, I want an e to the u. So my u is just going to be x. I'm trying to get it to match the other thing. So du dx is just going to be 1, or du is going to equal dx. And then I just have to change my bounds. So u of 0 is still going to be 0. U of 1 should still be 1. So I have the integral from 0 to 1. I have that 2. I'm going to suck that out front. I know that x is equal to u, so I have u. And then I have e to the u du, which is not the same as the previous integral, right? Because that's a 1 over u. This is a regular u. So I know that those two areas are not equal. So it's probably going to be this third one is going to equal one of the first two. Let's find out which one. So we have the integral from 0 to pi over 2 of e to the sine x sine 2x dx. All right, this one looks to be the trickiest one. U is going to be sine x. And then du dx then should be cosine x. Or du cosine dx. But now I'm a little worried here, because when I look at my integral, I don't have a cosine x anywhere in there, right? Look a little harder.
Oh, yeah, you can do the
Yeah, that's a double angle identity. Sine 2x is 2 sine x cosine x. Oh, Mr. Kulik, are you joking? I needed to remember that. In this one you did. Let's see. Sine of 0 is 0. Sine of pi over 2 is 1. So we have the integral from 0 to 1. E to the u. Now in place of we have this 2 there. I'm going to just pull that out front. I have the sine x, which is a u. And then I have cosine dx, which is just my du. And I notice now that those two are the same. Yeah, so I plugged in sine x is u, so I plugged that in there. And then cosine dx is du, so cosine dx became my du. And then I think everything else should be easy to see where it went to, right?
Yes.
So I'm not actually going to do the integration, because looking at these integrals that I have set up, even after the u sub, we don't know how to do those yet, right? U times e to the u, right? What are you going to do with that? I don't know. So we don't need to integrate it. Now, if you had a CAS calculator or whatever, you could type it in and get a number. Or even your regular TI calculators, you could type that in and get a number, and that'd be fine to go that route. I think the point of this, though, is to get you to do the U substitution, just figure out like which two are really the same integral, which is what we did here. But yeah, worth pointing out that if this was a calculator active question, I mean, you could have just evaluated this thing and like evaluated this thing and evaluated this thing. Just type them in your calculator and see which gives you the same decimal. That would be okay. Not incorrect to do that. It's just a question of like, what are we supposed to be using on this? So I did it as a no calculator problem to show you that like it's still possible with no calculator to do this. If you did have a calculator, I would have just done it numerically though. Right, you just plug in the integral into your calculator and press enter and just see which one of the three gives you the same number. Which may not have been faster because that's a lot of stuff to type in, but probably less likely to make a mistake and certainly easier to do than by hand. But does that feel okay, Blake?
Yeah.
As to what we did here? And good practice doing like the U substitution, right? if nothing else. Let's see. Blake's asked a question. Mackenzie, it's usually your turn now. Do you have one?
I do, if my OneNote would work.
Oh, that's frustrating, isn't it? Mia, do you want to go while Mackenzie's straightening her OneNote out? 5.562? Sure. Oops. Let me find that one. Well, that's itty bitty, isn't it? All right. So keep in mind that like you could type this in your calculator and just get the decimal. We're not interested in doing it that way. I'm going to do it by hand to demonstrate to you like how to do it by hand. But since it's a definite integral, all of our calculators can handle this, right? But this, I see one function inside of the other because I see a sine x inside of a sine x, or a sine inside of a sine x inside of a sine. So that's what I'm going to pick as my u. Du dx then is cosine x, or du is cosine x dx. So I have that part covered, and I have, oops, this part covered. So I think I'm doing pretty good. I'm just going to do u of 0, which we said already was 0, and u of pi over 2, which is 1. So this is the integral 0 to 1 of sine u du. So the antiderivative of sine is negative cosine. And because I did the change of bounds, I don't need to do anything funny there. So I just have cosine, or negative cosine 1 minus a negative cosine 0. So cosine of 0 is 1, right? So I'm going to have 1 minus cosine of 1, and I don't know what that is. I guess you could type in your calculator and get a decimal from it, but I'm fine with just writing it as 1 minus cosine 1. Is that okay? Looks scarier than it turned out to be, right? Yeah, it was very scary looking. Not so bad. Mackenzie, are you ready?
Yeah.
Excellent.
Can you do number 2
Oh, on the review?
Yeah.
Number 2? Sure. Okay. Let me actually do this. And we'll screen cap just that piece in there so I don't have to like put the whole page in there, right? And that probably makes life easier for everybody. All right. So to do this, I'm going to remember that my integral from a to b of f of x dx is equal to the limit as n approaches infinity, the sum from I equals 1 to n of f of xi comma delta, or times delta x. So that's kind of my starting point. So what I'm going to notice here is that that piece must be my delta x. This piece must be my xi. And then this piece must be my f. Is that okay, Mackenzie? Okay. So I remember that delta x equals b minus a over n. So if that's equal to 9 over n, that implies that b minus a has to equal 9. Feel so far so good? I remember that xi is equal to a plus I times delta x. So if that's 7 minus 9i over n, I can tell right away that a has to be 7. So if a is 7, that tells me that b has to be 16. And now I think I have everything I need. So I have the integral from 7 to 16 of the cube root of x dx. So not a lot of calculus really happened here, right? The big key was remembering this relationship and then those two things. And if you remembered all that, then it's pretty easy to piece the integral together. But those are just like stuff you have to remember, right? Yeah, no problem. And again, like that's a 5-2 question I think is doable in a test setting and doable time-wise. It's not like a whole sheet of paper to do that kind of thing. As opposed to like if I asked you to evaluate that sum or that limit or whatever is going to be like horrific. And in fact, that's not even one we could do because we don't have a summation formula for a cube root. There is one, but yuckarooskies. We're not deriving it. Happy to do more stuff with you guys. Do you want to do some more stuff? Blake?
Am I doing number 85?
85 on 5-5. Sure. You like these ones at the end, huh?
I do.
Let's see.
I really did.
Sometimes they're bad and sometimes they're just like, oh, that wasn't.
Yeah, I don't think this one doesn't seem like it has that hard of an answer, but I don't.
You can't see what to do with it. Yeah, sure. Okay. So what I'm going to do is I'm going to do a U substitution on this piece, and hopefully I'm going to end up with a integral from 0 to 4 f of u du, where I can just say that that part is 10.
Yeah.
So let's see what we can do there. So u is going to be 2x. So du dx is going to be 2. So du is just 2 dx. And really we're going to have du over 2 is dx. If I do u of 0, that's 0. U of 2 is 2 times 2, or 4. So putting that together, I have the integral from 0 to 4, f of u du over 2. So if I just take the 1/2 out front, I have exactly what was given here, except the variable name is different. Does the variable name being different matter?
No.
No, it's still just 10, right? So this is just 1/2 times 10, or 5. Again, looked kind of scary. It's like, I don't know what to do with this. But all we did was use substitution to make the one we're asked about look like the one we're given. So we can just like plug it in. Right? There's no way you're given something like this if you're not going to be plugging it in somewhere, somehow.
Yeah.
Right? So the goal was just to like, I got to get this thing to look like the other one. And the only way to do that is to get the 2x to just be a single variable. The way we do that is with use substitution. Isn't it frustrating on something you've like I spent 15 minutes playing around looking at that and I couldn't make heads or tails of it, and it just seemed like I should have been able to do that, and you did it in like a minute. Like, I'm kind of jealous. It's okay. I've spent a lot of time and money getting good at this, so don't feel jealous. Mia. 5 from the review? Sure. Let's see here. Turn on that. Okay. So when you printed it out, when did you, because we made these changes last time. Okay, so that's the key. Before it was, when I wrote these 2 questions, I had goofed them. I flip-flopped in my head, which, like an odd relation and an even relation did opposite things in my head when I wrote this. So once I've done that, everything works out. But let's go ahead and do it for realsies, right? But that's why when you're looking at it, you're like, what the heck do I do with this? Like, he had to have screwed something up here, because I can't do that. And you're right, you couldn't have. If it was even, I hear a whistle. All right, I think we did this, right? All right, so my first goal is to figure out, is this function here odd or even? To do that, I'm going to just do the composition of that function with negative x. Now I know x to the 4th, or negative x to the 4th, is just 4 negatives multiplied together, so that's going to be a positive. Tan of negative x, the odd even identity, says that's negative tangent. So I end up with negative f of x. So this is odd. Since it's odd and the upper bound and the lower bound are opposites, I know it integrates to 0. So it just boils down to showing that it's odd, is all I needed to really do. And again, I could have seen that just by looking at this, because I see even function times odd function should be an odd. But if you couldn't do that on site, which probably you can't, or you wouldn't think to even think about it that way, or even be sure enough when you're looking at it on the test that that looks odd to me. That's how you would check, though. Like, you just do the composition with a negative x and simplify and see what you get. That, and me, I think you probably would have gotten that had it. Yeah, I'm glad that when we talked about it, or when we looked at the review last time, I noticed that. But like, if you moved it earlier, when it first came up, when it first popped in there, you would have not had a lot of luck there with that one.
do an even one then, so like number 6.
Sure. Absolutely. Oops. And I think there was an update on this as well, right? Those x cubed had to turn into x to the fourths or something. Yeah, that's what I did. Okay. So first thing I'm going to do is I'm going to look at this and see if that's my f of x. I want to see if that's odd or even. Again, because I see the upper bound and lower bounds are opposites. So negative x to the fourth, cosine of negative x. Well, x to the fourth, or negative x to the fourth is just x to the fourth. Cosine of negative x is cosine x. So this is even. So I can say there then this integral is equal to 2 times the integral from 0 to a and we're told that that integral, but we have the thing that we're given is from negative a to 0, but that's okay, right? That this, what we've written here, is going to be the same thing as negative a to 0, right? It's just the right half of the area versus the left half of the area. Everybody can kind of see that. So it's still going to be the same thing. So we just end up with like 2 times 13,520, whatever that is.
But it's x to the fourth divided by cosine.
Oh, well, that's just a typo then. What was I doing here, Mr. Kulik? Yeah, you could not have done anything with this. This is a terrible question. You made 2 sets of mistakes in here. Yeah, I have no excuses, guys. It's just a bad day one apparently. So those functions just need to be the same thing. So either treat them as both times or both divides. Either way, they're both even functions, and yeah, I apologize. That's a bad one. Let me queue up the review and I'll fix these things and like repost the whole thing here at the next period because I have a minute to do that. I think 7 was okay though, right?
Yes, that was fine.
Okay, good. Yeah, my apologies, Mackenzie.
It's okay.
You should have looked at that and been like, I can't do anything with this. Which is good if that's where you're at. You're like, what are you doing, Mr. Kulik? You're in a good spot. So like, Sienna, you're asking like, why can I make that integral swap?
Oh, no.
No?
It's just explain.
Oh, okay.
It makes sense. Yeah, proper.
So like if this is negative a and this is positive a, let's draw it this way maybe. So like this area and this area have to be the same because they're symmetric about the y-axis. So whether I talk about the area from negative a to 0 or from 0 to a, they should be the same area if you're an even function. That's what allowed me to do that switcheroo for freebies. Mia. So like those odd even properties that we're using there, right? Like those are good ones to have. I think property 5 is the one that like takes your integral and you chunk it up into like a bunch of different bounds, right? Like if I have the integral from A to C, that's the integral from A to B plus the integral from B to C, right? That's what property 5 is. And then the other ones that would probably be the good ones, I think were not these ones. Nope, that's not what I'm looking for. Was it in 5.2? Maybe it was in 5.2. Oh yeah, there they are. These comparison properties would be good ones. Or if you have, in particular, like this one is the best one, I think, or the most useful one. That if you have one function that's always bigger than the other function, always higher than it, if I integrate those, you still have that same relationship that the area under the lesser function should be less than the area under the bigger function, which is very intuitive, but like it's kind of like it's just those are a couple of nice ones to have because you're able to like kind of build out like a squeeze theorem kind of situation where you have like one function is bounded by the other function is bounded by the other function. You can set up then the same relationship with the integrals, and then if you wanted to do like a limit of an integral or something. But that would be the other ones. Is that, yeah, that's aside from like your general antiderivative stuff, like those would be the things that I was thinking about. You know, like this stuff where you can distribute the integral, but we've been doing that all the time, like unconsciously, like you haven't even, or you pull the constant out front, or, you know, like normal stuff that we've been doing all the time. I don't even feel like I need to mention because we just automatically do it. But that's the kind of stuff when I talk about the properties, those are the sorts of things I'm talking about. But for the most part, it's just like those 5 or 6 that we just mentioned are the big ones that aren't like the obvious ones. You know what I'm saying? Okay. But this one should be a relatively focused test. This has been a pretty focused chapter with really one skill in it. It's just been like, how do you do integrals? Which should be pretty good, right? That should be a relief. Like a narrow test that's like one skill. Yeah. I think it'll be one that we can finish inside of one class period. I think Mr. Gullick's getting better at this. I'm not trying to make the test long on purpose. Part of it is like me getting to know, you know, like what's realistic for a class like this that I haven't taught a bunch of times before. You know what I mean? Cool. Happy to do some more. Do we have some more stuff you wanted to talk about? If you don't, that's okay. Mackenzie? Mm-hmm. Yeah, sure. Yep. All right. So you're given blah, 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 right? And we're asking to do a left-hand Riemann. So if I'm doing that, I have like 0, I have 23, 36, 48, and 60. So my first Riemann is going to have, since it's left, the height is going to come from f of 0. And since we're talking about running, what's your velocity at time 0? 0, right? So the first rectangle is like a nothing burger. The second rectangle is going to have height 9.8. And the width of that rectangle is, what, 13 or something? The next rectangle is from 36 to, or 36 to 48. The height there is, maybe we'll put the point there, is 10.1, and the width is 12. And then the last one, the width is 12, and the height there is 10.6. So it doesn't matter if the widths are different. You're just still finding the area of a rectangle, and the rectangles may not be uniform in size, and that's okay. Oh, yeah, thank you. Thank you. Yeah, and now there is a conversion that needs to happen, right? Because this is in minutes, this is in miles per hour. Yep, good job. So what are we going to do? Just take these and divide them by 60 to put them in hours, right?
Real quick, like use a right-handed Riemann sum just to.
It's going to be a lot bigger, isn't it?
Yeah.
Yeah, so here it would be,
Anything, just to.
yeah, I'll just draw them in. Oh, that one actually is the less one, right? Because 9.5 is like down there or something. So what do we have? We have like 9.8 for 23. And then we have 10.1 for 36. And we have, or not for 36, for 13. And then 12 here, but now our height is 9.5 on this one, and then our height here is 10.6, right? So if I'm doing a right, I have this whole extra big piece in there.
Why is it 10.6 and
Oh, it should be. Thank you. Yeah. So anyways, that's the dealio on this one. The widths of the rectangle don't really matter. You just, whatever the width is the width. That's fine. They don't have to be uniform rectangles. It's okay. But you did need to notice that and just go, oh, 13 for the first one, there'll almost be 13. You know what I mean? Like, but that's the gist of it. Did I do a good job of that on the review key when I did that one? Oh, so I kept everything in minutes and turned the miles per hour into miles per minute or whatever. That's fine. Oh, yeah. So that's why there's the 375, right? I guess I didn't read the question very well, did I, when I started doing it? I think that's for all of them. right? Because it just flat out tells you that's how far you went in the first 23 minutes, and then from there, all you're given are rates. So you're going to just have 3 rectangles, right? The only difference if you did a right-hand Riemann sum is you'd be using those 3 as your heights, as opposed to on a left Riemann sum where you use those 3. You know what I mean? Sorry about that. Yeah, this is supposed to be 9.5. And then we added the 375 to it. So again, Mackenzie, that to your question, the width of the rectangle just can be different. That's fine. You're still making an approximation by just adding up areas of rectangles. The rectangles may have different sizes. No biggie. Worth mentioning, remember that the review's not an assignment. You don't need to do it and turn it into your OneNote if you don't want to. I mean, you can put it in there. It's just for you to work on or whatever. I feel like the problem sets are enough. You know what I'm saying? This, I just want you to, like, you know, give you something to look at that's written by the same person that's writing your test as opposed to written by the author of the textbook. I don't feel like it was considerably different, the kinds of problems I put in here, than the kinds of problems you guys saw, right? Not massively different anyways. Okay?
I did put 5.2 in my homework set.
Yeah, I
I
noticed.
just realized that.
I figured it was just an oversight, but anything more for me? You guys can, if you don't, we can just spend the rest of the time working on your stuffs, whether reviews or problem set or whatever. If you have individual questions, feel free to come on up and holler at me or whatever. But you guys are scheduled for test on what would be Monday next week, right? I know that's scary, the Monday test day, but
Monday at 7 a.m., baby.
7 a.m.
7:45. That's
Okay,
right.
I was like 7 a.m.